Hello student. In previous class I discussed about the emission spectrum of hydrogen. There are different series found in the emission spectrum of hydrogen. One is the Lyman series, second is the Balmer series, third is the Pascal series, fourth is the Bracket series, fifth is the Pfond series, sixth is the Humphrey series. These are drawn in the diagram here. I have given already given in this diagram what is Lyman series, what is Balmer series, what is Pascal series, what is Bracket series, what is Pfond series, what is Humphrey series. For each series, I have calculated the wave number and wavelength. These are the equation. Basing upon the wavelength and wave number, I have also completed some problem. These are the few problem. I have completed problem number 1. Next is your problem number 2. Next, I have also completed what is electromagnetic spectrum. I have also given an example. I have also draw a diagrammatical representation to show the different electromagnetic spectrum arrangement. There are different electromagnetic spectrum. One is the cosmic ray, gamma ray, X-ray, ultraviolet ray, visible ray, infrared, microwave, radio wave. They are arranged according to the increasing order of the wavelength or decreasing order of the frequency. Next, I have also completed solar spectrum. When white light is passed through the slit, when white light of the sun pass through the slit, then the beam will strike the prism. Then the beam is subject strike to the photographic plate. Then the photographic plate is affected, and when you will analyze or when someone analyze the photographic plate by using the spectrometer, then it shows 7 color, that is denoted as VV gyro. In this class, I will explain about a new concept, that is your Planck's quantum theory. What is Planck's quantum theory? It is a very important question. It will come in the exam. Is it 2 or 3 mark? Question is, what are the postulates of Planck's quantum theory? What are the postulates of Planck's quantum theory? It is an important question. Then you will write the answer, write the 4 points in the answer. As for the postulates of Planck's quantum theory, Planck said that whether you will take a source, whether it emit or absorb energy, suppose I will take a body, whether the body absorb or emit energy, it always emit or absorb energy in the form of small pockets. These pockets are emitted from the source, that is your by the body or from the body in the discontinuously. This is the first point. So here I can say that the energy is absorbed or emitted by a body discontinuously in the form of small packet. Next point is each packet of energy is called quantum. This is your said to be, that is your quantum. In case of light, the quantum is called photon. In case of light, a special word is your use, that is your photon. But all the case, but except the light, you can say that is your quantum. And the energy of photon is measured by the equation E is equal to h nu. This is the equation. Here I can say that E is equal to h nu, where h is the Planck's constant, nu is the frequency. That is your nu is your what? Frequency. Nu is your frequency. So here I can say that the energy of photon depends upon the frequency of radiation, that is E is equal to h nu, where h is equal to Planck's constant, nu is equal to frequency. Remember, the energy of the small pocket, the energy of the photon always h nu or 2h nu or 3h nu or 4h nu, like that. That means the h nu multiplied must be multiplied with the whole number. Whole number means n is equal to 1, 2, 3, like this. but it cannot multiply with the fraction 1.2, 1.75, like that. That means when a body having energy 1.2 h nu, then it cannot emit or absorb any energy. When a body having energy 2.1 h nu, it is a fraction value. It cannot emit or absorb by anybody. So here Planck's quantum theory says that a body can absorb or emit energy only sorry, I can again I want to write I want to read again. A body can absorb or emit only one photon or some whole number multiple of it. That means it can emit h nu, 2 h nu, 3 h nu, 4 h nu, but it cannot emit to 1.2 h nu, 1.75 h nu, like that. This is all about the Planck's quantum theory. If you will write 4 points in the answer sheet, then we will get 3 or 2 marks. Next, move to the dual nature of matter. What is dual nature of matter? Remember, dual nature of matter means you generally think about the wave character. One is the wave, that is your another is your particle. One is the particle character, and second is the wave character. According to Einstein, light has dual character. Light has a dual character. That is your it have a particle character. Another is your wave character. This is explained by the scientist Einstein. But de Broglie suggested that our universe is made by two things. One is the light, another is the matter. Then, by comparing these two concepts, by comparing the concept of Einstein and comparing the concept of de Broglie's, when both the concepts are compared, then it can be said that if light has dual character, that means it is the one component of the universe. That means the second component must have also dual character. That is, matter have dual character. So here we can conclude that if light has dual character, then matter also has a dual character. We know that matter is made by some molecules. Molecule is made by what? Atoms. Atom is made by what? Subatom. Subatom means that is your what? Electron, proton, neutron. Subatom means electron, proton, neutron. Look at that. If our inverse is made by light and matter, if light have dual character, matter have also dual character. If matter have dual character, that is your wave character, and another is your particle character, then molecule is must have dual character. If molecule have dual character, atom must have dual character. If atom have dual character, then the subatom have also dual character. Subatom having dual character means electron, proton, neutron, both three are having the dual character. One is the particle character, one is the wave character. This is the dual nature of matter. Now I want to move to the de Broglie's wave equation. This is given by the scientist de Broglie, and the de Broglie's wave equation is given here. Lambda is equal to h by mv is equal to h by p, where p is equal to mv, where p you can say that is your said to be momentum. And here I can say that m is the mass of particle, v is the velocity of particle, lambda is the wavelength, h is the Planck's constant. Remember this term. This is said to be de Broglie's wave equation. That is your lambda is equal to h by mv is equal to h by p. Our target to prove h lambda is equal to h by mv or h by b. It is a very important question. Sometimes in exam 2 or 3 mark question will ask like this. Derive the de Broglie's wave equation. Then you will derive. Let me derive. We know that according to the Planck's equation, here I can say that E is equal to h nu. It is already said in the Planck's quantum theory postulates. Look at that. Here I have written E is equal to h nu. So from the Planck's equation, here we can say that E is equal to how much? H nu. Here E is the energy of photon of light and H is the Planck's constant, nu is the frequency of the wave associated with the photon. Similarly, if you think about the Einstein equation, Einstein says that E is equal to mc square. Planck gives E is equal to h nu. Einstein gives E is equal to mc square. I have given E is equal to h nu as a equation 1. I have also given E is equal to mc square, that is your equation 2. If you think about the equation, if you, here m is the mass, c is the velocity of light. If you think about the equation 1 and 2, from equation 1 and 2, we can say that in the left side, both terms are e. That means they are equal. Look at that. Here, in equation 1, in the left side, e is present. In equation 2, in the left side, e also present. So here I can say that if left side are equal, then right side also equal. So here we can say that from equation 1 and 2, here I can write h nu is equal to mc square. This is your equation 3. Again, we know that nu is equal to c by lambda. Again, what? Nu is equal to c by lambda. Nu means that is your, nu means what? Frequency. Nu means your frequency. C means what? Velocity of light. This is your velocity of light. And lambda means your wavelength. Lambda means your wavelength. Clear? H nu is equal to mc square, that is your equation 3. Lambda is equal to c by lambda, that is your equation 4. Now put the value of nu in equation 3. So here I can write from equation 3 and 4, here I can write sc by lambda equal to mc square. Now here look at that, here c is present, here c square is present, so here I can cancel one c. So here I can write h by lambda is equal to mc. Here I can write h is equal to mc. That means here I can write lambda is equal to h by mc. Here c is the velocity of light. If you think about the lambda value for an electron, which mass is your m, velocity is your v. Or particularly the velocity of light is denoted by c. But for any other species, you can write the general term, that is your v. So here I can say that for material particles, so an electron with mass m, velocity v, equation 5 can be written as lambda is equal to h by mv. This is your equation 6. We know that p is equal to mv. From equation here p means momentum of the particle. From equation 6 and 7, if you will compare equation 6 and 7, look at that. Here mv is given, here mv is given. So we can change the mv and put the value and put p. That means here I can write lambda is equal to h by mv. This is the original equation. Next, instead of mv, I can write p. So here I can write lambda is equal to h by mv is equal to h by p. This is your de Broglie's wave equation. This is your said to be what? De Broglie's wave equation. What is the significance of de Broglie's wave equation? This equation is more applicable to for the microscope body. When you want to measure the wavelength or mass or velocity, then you generally use this equation, that is your lambda is equal to h by mv is equal to h by p. By using this equation, you can easily or correctly calculate the mass, velocity, wavelength of a microscopic body. This equation helps to calculate the wavelength. Already we know wavelength, frequency, velocity, mass, like that. This equation helps to calculate the angular momentum. Obviously, this is your we know that if we know that mv is equal to p, that means mvr is equal to pr. If we know the momentum, then multiplied with the radius, then we can find out the angular momentum. So here I can write mvr is equal to nh by 2 pi. This is the formula. Remember, mvr equal to nh by 2 pi. This is the, again I want to read the significance. This equation is more applicable to microscope body. This equation helps to calculate the wavelength value. Next, this equation helps to calculate the angular momentum. Next, I want to do some problem related to the de Broglie's wave equation. Let me explain. This is problem number 1. A 100-watt ball. A 100-watt ball emits electromagnetic light of wavelength that is 400 nanometer. Calculate the number of photon emitted per second by the ball. At first, I want to write the given terms. Look at that. Your 100-watt ball means it emit 100 joule per second. So here I can write energy emitted by the ball means that is your 100 watt is equal to 100 joule per second. This is the value, and here we can say that energy emitted by the bulb is equal to 100 joule per second. Here lambda is given, that is your 400 nm. So here I can write wavelength lambda is equal to 400 nm. Now we can convert this value into what? Meter. Here it is not necessary to write meter per second. Only write the meter. Why it is written meter per second? No, this is not necessary to write wavelength. Wavelength is equal to 4 nanometer. Why? Next, here we can find why it is necessary to write. Not necessary to write. That is your meter. Okay, good. Here I have wrong. Look at that. The given data is your energy emitted by the bulb is your 100 joule per second. Wavelength is equal to 400 nanometer is equal to 400 into 10 to the power minus 400 into 10 to the power minus 9 meter. This is the wavelength. We know that. We know that the energy of photon is equal to hc by lambda. This is the formula. E is equal to hc by lambda. Here we know that h, the value of h is your what? Planck's constant is your 6.626 into 10 to the power minus 34 joule into second. This is the value. Look at that. Here h is given. Velocity of light is 3 into 10 to the power 8 meter per second. Clear? Now put the value of h. H means 6.626 into 10 to the minus 34 joule into second, and put the value of c, that is your 3 into 10 to the 8 meter per second, and put the value of lambda. Lambda is your 400 10 to the 9 400 into 10 to the minus 9 meter. So here when I will put the value, I can write E is equal to, that is the energy of one photon. Energy of one photon is equal to how much? 6.626 into 10 to the minus 34 joule into second into 3 into 10 to the 8 meter per second divided by 400 into 10 to the minus 9 meter. Here we can cancel meter. Here we can cancel second and second inverse. It is highly necessary to convert the nm into the meter. Otherwise, they cannot cancel, because we know that the velocity of light is your 3 into 10 to the power 8 meter per second. Here meter per second is given. So it is very easy to convert the nanometer to meter, then put the value and you can cancel each other. So here I can say that the energy of one photon is your 4.965 into 10 to the power minus 19 coulomb. Our target is what? Calculate the number of photon emitted per second by the volume. Actually, the energy of one photon is this amount. We again know that number of photon emitted per second. Number of photon emitted per second means total energy emitted by the bulb divided by energy of one photon. How many numbers of photon are emitted? If you want to calculate, again I want to repeat, how many number of photon emitted per second, if you want to calculate, then you generally found the total energy emitted by the bulb divided by energy of one photon. This is the formula. Our target to find out the number of photon emitted per second by bulb. Look at that. Here the 100 watt is given. That is your 100 joule per second. In 1 second, the energy emitted by the bulb is your 100 joule. So I have written here that is your 100. Total energy emitted by the bulb is your 100. Divide by how much energy of one photon. Energy of photon already calculate. This is the value of energy of photon. 4.965 into 10 to the minus 19 joule. Now put this. So here I can say that number of photon emitted per second is your 100 minus 4.965 into 10 to the minus 19. If you want to solve, then the answer is your 2.01 into 10 to the power 20. This is the answer. Clear? So here I can say that number of photon emitted per second is your 2.01 into 10 to the power 20. Again I want to repeat, the number of photon emitted per second is your 2.01 into 10 to the power 20. Next I want to move to the problem number 2. Calculate the energy of one molecule of photon radiation whose frequency is 5 into 10 to the power 14 hertz. Our target to find out the energy of one mole of photon. At first, find energy of at least one photon. Energy of one photon. If you will find the energy of one photon, then you can calculate the one mole of energy of one mole of photon. How you will calculate? Multiply the energy of one photon with 6.023 in 10 to the 23. 1 mole means it is equal to 6.023 in 10 to the 23. So our target first to find the energy of one photon. Before going to solve before going to solve before going to calculate the energy of one photon, remember what are the given data. Calculate the energy of one mole of photon of radiation whose frequency is given, that is your nu. So here I can write nu is equal to, that is your 5 into 10 to the power 14 hertz equal to 5 into 10 to the power 14 second inverse. This is the frequency value given. I have written here. We know that energy of photon is equal to h nu. H is the Planck's constant. Planck's constant means it is equal to 6.626 into 10 to the power minus 34 joule into second. Here we know that E is equal to h nu. Nu is equal to 5 into 10 to the 14 second inverse. Now put the value of nu. This is nu, not V. This is nu. Now put the value of nu and h in this equation. So here I can write energy of a photon is equal to h nu is equal to 6.626 in 10 to the 34 joule into second. Next, then I have written the value of nu, that is your here I can multiply it with the 5 into 10 to the power 14 second inverse. Second inverse second can cancel. Here I can write the value is your 3.313 into 10 to the power minus 19 joule. This is the energy of one photon. For the calculation of energy of one mole of photon, here we can multiply this value with Avogadro's number, because one mole means Avogadro's number. So here I can write energy of one mole of photon is equal to 3.313 into 10 to the minus 19 joule into 6.023 into 10 to the 23. After some solution, it is seen that the value is equal to 199.51 into 10 to the 3 joule per mole, which can be converted into kilojoule. Then here I can write 199.51 kilojoule per mole inverse. Our target to find out the in the question, our target was to find out the frequency, sorry, find out the energy of 1 mole of water. So this is the value 199.51 kilojoule per mole. So here I can write the energy of 1 mole of photon of radiation is your 199.51 kilojoule mole inverse. Next, such type of problem carry 2 marks. These are very important question. It will carry 2 mark. Next is your the difference between matter wave and electromagnetic wave. It is an important 2 mark or 3 mark. What is matter wave and what is electromagnetic wave? Remember, first point, matter wave. Actually, if you think about the matter wave and electromagnetic wave, electromagnetic wave travels at a speed of light. The speed of light is equal to the speed of the electromagnetic wave. But if you think about the matter wave, the speed of matter wave is very much less than that of the electromagnetic wave. The speed of electromagnetic wave is very less than the speed of matter wave. This is the first point. Next point is matter wave cannot be radiated in the space. But electromagnetic wave can be radiated and propagate in space. Next, matter wave are associated with the particles and are not emitted by them. Next, electromagnetic wave are emitted as energy wave. Matter wave have smaller wavelength. Electromagnetic wave have completely larger wavelength. This is the difference. This carry 2 or 3 mark. So remember and try to understand. Now move some important point which are covered in a note. All type of electromagnetic radiation travel with the same velocity, but their wavelength and frequency are different. Obviously, the speed of the electromagnetic wave of different. Again, I want to say that the speed of electromagnetic wave, that is your same velocity. They have the same velocity. All electromagnetic radiation travel with the same velocity, but their wavelength and frequency will change. Lambda value and nu value must be changed for each electromagnetic radiation, but they have the same velocity. This is the first point. And matter wave, that is your de Broglie wave. Matter wave is also termed as de Broglie wave. It is a hypothetical wave. Such type of wave cannot found. It is taken hypothetically. So here I can say that a matter wave or de Broglie wave is a hypothetical wave associated with the motion of an atomic or subatomic particle. Next, it explains the effect such as diffraction of particle by crystal. There are different points regarding about the matter wave. Actually, remember simply matter wave is a hypothetical wave which is associated with motion of an atomic or subatomic particle, and it explains effects such as diffraction of particle by crystal. Remember, suppose a body have dual character. Suppose light. Think about the light. Light have dual character. One is the particle character, another is the wave character. For proving the particle character of the light, generally the reflection and refraction experiment are carried out. For proving whether the light is having wave nature or not, for proving such type of thing, generally interference and diffraction are carried out, and the interference and diffraction property that shows the wave nature of the matter. Reflection and diffraction shows the particle nature of matter. Interference and diffraction shows the wave nature of the matter. Next, move to the Heisenberg's uncertain principle. This is also carry 2 or 3 mark. In exam, a question will ask like this: state and explain Heisenberg's uncertain principle. Then, what is the statement? What is the main importance of Heisenberg's uncertain principle? And I want to explain this. According to Heisenberg uncertain principle, it is not possible to measure simultaneously both the position and momentum or velocity of a moving microscope particle with absolute accuracy. Suppose this is a microscopic particle. It uh, move. Sorry, I want to that. It is impossible to measure simultaneously both the position and momentum or velocity of a moving microscopic particle. Suppose here a moving microscope particle is present. Suppose someone try to find the exact position of this microscopic particle. When you want to determine the exact position of a microscopic particle, then you generally need some energy in terms of light. When you want to see in which position the microscope particle is present, then you will use the light or apply the energy in the small amount of energy. Suppose a microscope particle is present here. When you want to see the microscope particle in which position it is present, you will use the energy, that is your light, to see the microscope particle. When the microscope particle come in contact with the light, then what will happen? The microscope particle will change the original position to any other position, maybe this side, maybe this side. So we cannot calculate the exact position. Similarly, if you want to calculate the velocity of the microscope particle, obviously you use the instrument. When you will use the instrument, then it emit energy. Then such emitted energy is absorbed by the small microscope particle. As a result, what will happen? The speed of the microscopic particle will increase. That means if you want to measure the position exactly, then the momentum or velocity will not measured exactly. That means they are measured simultaneously. But if in a particular time, suppose I want to measure this microscope particle, that is your position. At the same time, we cannot exactly measure the momentum or velocity of the moving microscope particle with the absolute accuracy. There is a deviation in the exactness. So, what is the statement? It is not possible to measure simultaneously both the position and momentum or velocity of a moving microscope particle with the absolute accuracy. Here, the position is said to be what? Uncertainty. Here, the position is said to be uncertainty. Here, the momentum is also uncertainty. So, to denote the uncertainty in position, here I can use del x. Del x means uncertainty in position. Del p means uncertainty in momentum. H is the Planck's constant. The value of pi is 3.14. So, mathematically, Heisenberg uncertainty principle says that del x into del p nearly equal to h by 2 pi. This is the mathematical representation for Heisenberg uncertainty principle. Here we can say that del p is the momentum. Remember, p is the momentum, but del p is the uncertainty in momentum. When you want to think about p is equal to generally mv. But when you think about the del p, then you can say that is your m del v. Here the m value, here we have taken, there is a certainty of m value. But here we cannot say that the velocity is having certainty. So here del have is the uncertainty in velocity. Del have is said to be uncertainty in velocity. Now compare the equation 1 and equation 2. Here we can write del x. This is your del x. Del x here also del x into del p means m into del v. Simply you can find del x into del v is equal to hy how much h by 2 pi. Put the value of mv. Here we can say that the uncertainty is an uncertainty is your del x into del v is equal to, that is your 2 pi m. This is not 4. This is your 2 pi m because m value will come here. M value will come here. That is your 2 pi m. So this is the statement and explanation of Heisenberg's uncertainty principle. Again, I want to state the Heisenberg's uncertainty principle. Simply remember, simultaneously you cannot measure position, momentum, or velocity exactly. There is a not there is a small there must be some small error. You cannot give the exact value of position, momentum, or velocity. We cannot give the exact value of position, momentum, or velocity simultaneously. Mathematically, you can say that del x into del p nearly equal to h by 2 pi. Then you can modify the del p, change the del p. You can write del x into del v is equal to nearly equal to h by 2 pi m. Next, what are the significance of Heisenberg's uncertainty principle? These principles apply to the moving microscope particles like electron. This principle have proving that electron cannot exist in the nucleus. This principle has no significance for microscopic object. Sorry, this is not micro, this is the macroscopic object. Remember, this principle have more significance to the moving microscopic particle like electron. This principle have proving that electron cannot exist in the nucleus. This principle has no significance for the macroscopic object. Next, I want to solve some problem related to the Heisenberg uncertainty principle. Problem, let me explain about the problem number 1. Calculate the uncertainty in velocity of a cricket ball having mass 150 gram. If the uncertainty in its position is the order of 1 angstrom, your H value is given 6.6 into 10 to the minus 34 kg into meter square into second inverse. From the question, here I can write m is equal to 150 gram. H is equal to already we know 6.6 into 10 to the minus, that is your 10 to the power minus 34. H is equal to what? How much? 6.6 into 10 to the power minus 34 kilogram into meter square second inverse. Then other value is your what? Uncertainty in your position. That is your del x. Del x is your how much? That is your 1 angstrom. It can be converted into how much? 10 to the power minus 10 meter. We know that 1 angstrom is equal to 10 to the minus 8, 10 to the minus 8 centimeter. If you think about in meter, then here you can say that 1 angstrom is equal to 10 to the power minus 10 meter. Here del x onset unit position is given. Our target to find out the onset unit velocity. That means del v. We know that here another term is given, that is a mass is your 150 gram. In kg you can write 0.150 kg. Already here I have written mass is equal to 150 gram. You can convert into kg. According to the Heisenberg uncertain principle, your del x into del p is equal to how much? H by 4 pi. H by 4 pi. Let me verify. What is the this is Planck's quantum theory. Yes, yes. Sorry. The value is your how much? H by 4 pi. Again, I want to change this. Here also I want to change. Here not 2, that is your 4 pi. That means here I can say that these are all are 4 pi. Again, I want to repeat del x into del p nearly equal to h by 4 pi. Then del p is equal to m into del v. Put this value. Then here I can say that del x into m into del v is equal to h by 4 pi. Then del x into del v is equal to, that is your h by 4 pi m. Okay. Next, move to the problem. Your mass is given, h is given, del x is given. Now put the value. We know that del x into del p is equal to h by 4 pi. Del p is equal to how much? M into del v. Now put this. Here I can write del x into m del v is equal to h by 4 pi. Now put the value of m, del v, del x. Sorry, our target to find out the del v. Now put the value of del x and m. So here I can write del v is equal to how much? H by 4 pi m del x. Now put the value of m del x, pi, also pi h. H is the Planck's constant. The value is 6.6 into 10 to the minus 34 kg into meter square into second inverse. Next is the pi, next is the 4. Then value of pi is equal to 20 by 7. You can also apply 3.14. Mass of ball is your 0.15 kilogram. Next is your del x. Del x is the del x is the uncertainty in position, and the value is your how much? 10 to the minus 10 meter. That means here I can write 1 into 10 to the minus 10 meter. 10 to the 1 10 to the minus 10 meter. So here I can finally say that del V is equal to 6.6 into minus 34 kg into meter square second inverse divided by 4 into 22 by 7 into 0.150 kg into 1 into 10 to the minus 10 10 to the minus 10 meter. Now solve this. After solving, you can find 3.5 into 10 to the minus 24 meter per second. So here I can say that the uncertainty in velocity of the cricket ball is your 3.5 into 10 to the minus 24 meter into second inverse. Let me solve the problem number 2. Similarly, you can apply. Calculate the product of uncertainty in position or displacement. That means our target to find out del x into del v. Our target to find out this term. To find this term, some data are given. Again, I want to read calculate the product of uncertain position or displacement and velocity for an electron of mass that is a 3.1 into 10 to the minus 31 kg. According to Heisenberg uncertain principle, here H value is given. That is your 6.6 into 10 to the minus 34 kg into meter square into second inverse. Here I can write mass of electron is your 9.1. Sorry, the value is here given wrong. That is your, you can write 9.1 into 10 to the power minus 31 kg. This is the mass of electron. Then H value is given. H is your how much? 6.6 in 10 to the power 6.6 in 10 to the power minus 34 kilogram meter square second inverse. Okay. Our target to find out the del x into del p according to Heisenberg uncertainty principle. We know that del x into del p is equal to how much? H by 4 pi. Our target to find out the del x into del v. So put the value of del p is equal to m into del v. So here I can write del x into m into del v is equal to h by 4 pi. Now find del x and into del v. This is our target to find. Del x into del v is equal to how much? H by 4 pi m. Put the value of h. This is the value 6.6 into 10 to the minus 34. Put the value of pi, that is your 3.14. Put the value of m, that is your 9.1 into 10 to the minus 31 kg. If you will solve, then the answer is your 5.8 into 10 to the 10 to the minus 5 meter square second inverse. This is your problem number 1. So here I can say that the product of uncertainty in position or displacement and velocity for an electron is your 5.8 into 10 to the power minus 5 meter square second inverse. Next, move to the problem number 3. Using uncertain principle, calculate the uncertainty in velocity of an electron if the uncertainty position del x is given, that is your 10 to the minus 11 meter. Given h value is your given, that is your 6.6 in 10 to the minus 34 kg into meter square second inverse. Mass of an electron is your already given, that is your 3.1 in 10 to the minus 31 kg. The given data del x is your 10 to the minus 11 meter. M is your 3.1 in 10 to the minus 31 kg. Apply our target to find out the del v. We know that del v is equal to how much? This is the formula. H by 4 pi m del x. Put the value of del x, that is your 10 to the minus 10, that is sorry 10 to the minus 11 meter. This is the del x value. M is the mass of electron, that is your 9.1 in 10 to the minus 31 kg. Put the value of pi, pi means that is your 22 by 7. Put the value of h, that is your 6.6 in 10 to the minus 34 kg into meter square second inverse. That means here I can say that del v is equal to how much? 6.6 into 10 to the minus 34 kg into meter square second inverse divided by 4 into 22 by 7 into 9.1 into 10 to the minus 31 kg into 10 to the minus 11 meter. If you will solve, then the answer is your 5.77 into 10 to the 6 meter into second inverse. So here I can say that the uncertainty in velocity of the electron is your how much? 5.77 into 10 to the 6 into meter into second inverse. This is the answer. Next, move to the problem number 4. Same style, you can do all type of problem. The uncertainty momentum, that means del p is given. Del p is your 3 into 10 to the minus 2 kg into meter into second inverse. Calculate the uncertainty in position. Here I can write del P is equal to 3 into 10 to the minus 2 kg into meter into second inverse. According to Heisenberg, del x in del P is your how much? H by 4 pi. Value of H is your 6.6. Again, I want to remember value of H is your how much? That is your 6.6 into 10 to the minus 34. Here we can say that 6.6 into 10 to the minus 34. You can put the value of H 6.6 or you can put 6.626 in 10 to the power minus 34. Actually, this is the exact value. 6.626 into 10 to the minus 34. This is the exact value. But in some problem, this value is given. So, if the value is given, that is a 6.6, then it is compulsory to write to put the value. If the value is not given, then you can put the general value, that is your 6.626 into 10 to the minus 34. Here no h value is given, so automatically I have written here, and that is your 6.626 into 10 to the minus 34. So here I can write according to Heisenberg uncertainty principle, del x in del p is equal to how much? That is your equal to h by 4 pi. Now del x is your how much? H by 4 pi del p. Put the value of pi, del p and h. Here I can write like this. There is a slight change. Here I can write 6.626 into 10 to the minus 34. You can write the unit hg meter square second inverse. Divide by 4 into pi means the 3.14. Here 3.14 is written later. So here I can write 4 into 3.14 into del p means 3 into 10 to the minus 2 kg meter second inverse. Now you can solve this and you will find an answer, that is your 1.752 into 10 to the minus 33 meter. So here I can say that the uncertainty in position is 1.752 into 10 to the minus 33 meter. This is the answer. Next, move to the problem number 5. Same style you can solve. The uncertainty position and velocity of particle is 10 to the minus 10 meter, 5.27 in 10 to the 24 meter second inverse. So here I can write del x is your 10 to the minus 10 meter, del v that is your 5.27 10 to the minus 24 meter into second inverse. Apply the Heisenberg uncertainty principle. Del x into del p. Here I can say that del x. Here I can say that, don't write this, del x into del p equal to h by 4 pi. Our target to find out what? Mass of particle. We know that del p equal to m into del v. Now put this value here. You can write del x into m into del v equal to h by 4 pi. Look at that. Here you can say that m is equal to how much? M is equal to h by 4 pi into del x into del v. If you will put the value of h, pi, del x, del v, then you can able to find the value of m. Here del x is given, so I can put it. Here del v is given, here I can write pi means 3.14. You can take 3.142 or you can take 3.14. H is the 6.626 into 10 to the minus 34 into joule into second. So now I can write mass equal to 6.626 into 10 to the minus 34 joule into second. Divide by 4 into 3.142 into 5.26 5.27 into 10 to the minus 24 into meter into second inverse into del v means, sorry, here del x means 10 to the minus 10 meter. Actually, as per the formula, the value of mass is equal to h means 6.626 into 10 to the minus 34 joule into second. Here I can write 4. Pi means 3.142. Value of del x. Del x is your how much? Del x is your 10 to the power minus 10 meter. Next, that is your what? Del v. Del v means is your 5.27 into 10 to the minus 24 meter into second inverse. This is the value. Now solve this. When you want to solve this, then what will be the answer? Here I have written repeatedly. Yes, I want to correct this. If you want to solve this value, if you want to solve this value, then you will find 0.999 kg, or you can say that 99.9 gram, that is nearly equal to 100 gram. So the mass of particle is your 100 gram. Like this problem, you can solve another problem. Problem number 6. An electron has a speed that is your 300 meter per second. Accurate up to 0.001%. What is the uncertainty in the locating its position? That means del x. Your target to find out the del x. Mass of electron is given, that is your 9.1 into 10 to the minus 31 kg. Look at that. Here speed is given, that is your 300 meter per second, and it accuracy is your 0.01 percentage. Then what is the exact value? Tell me. Here you can write del u is equal to what? Percentage means 0.001 divided by 100. Then you can multiply it with 300. Then what is your answer? 0.003 meter into second inverse. So here I can write del is equal to 0.00, sorry, here del is equal to 0.003 meter into second inverse. This is the value of del u. Next, del u, or you can say that is your what? Del v. You can take del u, del v. Mass of electron is your 9.1 into 10 to the minus 31 kg. According to HUP means Heisenberg uncertain principle. According to Heisenberg uncertain principle, I can write like this: del x into del p is equal to h by 4 pi. We know that del p is equal to how much? M into del v. Put this value, you can write del x into m into del v equal to h by 4 pi. Now put the value of each term. Our target to find out what? Our target is find out the uncertainty location. That means del x. Look at the formula. Del x into m into del v equal to h by 4 pi. Del x, here I can write del x. What is the value of m? M is 9.1 into 10 to the minus 31 kg. What is the value of del v? That is your 0.003 meter into second inverse. Next, h value is your 6.626 into 10 to the minus 34 into joule into second. Next, here I can write 4. Pi means 3.142. This is the what? Equation. If you want to simplify, here I can write del x is equal to how much? Change all the terms. 6.626 into 10 to the minus 34 joule divide by 4 into 3.142 into 9.1 into 10 to the minus 31 kg into 0.003 meter into second inverse. If you want to solve this is the simplification. If you want to solve this, then you will find an answer 1.948 into 10 to the minus 2 meter. So here I can say that the uncertainty in position is your 9.948 sorry, 1 point. Here the uncertain position is your how much? 1.948 into 10 to the power minus 2 meter. This is the answer. This is all about for today class. So here I want to stop the class. Namaste.